Hello and welcome back grade 12 to Maski Learning with Teacher Thandi and Maski TV. We are here to support as usual and make sure that you guys learn and understand how to respond to an examination question paper with trigonometry. Let's hit the ground. I am very sure that at this point you guys have your water, have your pens and have your calculator with you, as well as a paper that we need to write or a book so that you have reference going forward. So at the end of this lesson we should be able to work on compound and double angles and identities that we already know, as well as use them to solve their exam type questions. We are going to show you some errors that were done by other people before you that will help you, and you need to be able to avoid them. So let's see, from the 2024 diagnostic report, we have extracted some common mistakes that were done. One of it is when learners are writing a distance, which is radius or r, when you are dealing with trigonometry, as a negative answer. So remember, a distance can never be negative, it has to be positive. So the correct answer will therefore be r equals just 5 without a negative. The other one is where they make a mistake when they have to write a double angle of cos. Instead of writing it as cos squared of a minus sine squared of a, they just take the 2 from the angle to be the coefficient. So you can see what is the error there, right? So please pay attention to that. Also, when you are sketching your Cartesian plane quadrant kind of a diagram, which usually is the first question, please remember to look at what it is that they're saying the quadrant is about according to the intervals, and don't make a mistake or error while you are placing the angles and also the lines. Then also you need to know how to expand and when not to expand, because if you expand too much you might end up having errors. Just remember, the angles are not representing the ratios. So a practical example will be, if you have cos of an angle A equals 2 divided by 6 or 2 divided by, let's just use 5. Let's say 2 divided by 5. If you had it like that, remember this is not an angle, but it's a ratio, right? So the angle and the ratio is not the same. For you to find the angle, remember to always just find the arc cos. For example, in this one of 2 divided by 5, which you use your shift calculator to get to the answer, right? So you say shift, cos, and the answer for you to get into this answer and the ratio for you to get into that answer. So please bear in mind, because that is the error that others are doing for them to not be able to answer the question productively. One other one is when you are given a double angle, when you are given a compound angle, a cos equals bracket x plus y. Instead of using directly from the information sheet, which we call a formula sheet, please try to relate to what you are given and see how you're going to do it. So with this diagnostic report that we have here, we decided to then use 2024 question paper for you to see the errors that we are talking about and then how we're going to avoid them. Okay, so when we are doing the questions, just remember that some had used the wrong reduction formula instead of writing it correctly, or they are writing the compound and also the double angle formula incorrectly. How they factorize also, it's a mistake, so we'll go through that provided we have enough time for you guys to see, and also how to deal with the maximum and minimum value when you are not really given a graph but an equation. Okay. So please also here be very careful of which quadrant you are using and check if it's correct, especially when you are responding to the question. A very quick recap, we have this which we have learned from grade 10, a soccer tour, which you just know its sine is opposite of hypotenuse, and also cos is adjacent of hypotenuse, as well as tangent. It's equals to opposite divided by adjacent. Always remember to identify your right angle, the triangle, if you have to use this, because that's what will help you to get the right answer, which shows that we have 90 degrees on the right angle triangle. Also identify your reference angle, as well as labeling the sides, opposite, adjacent, and hypotenuse. Very, very important. Grade 12, please make sure that you can remember that. And again, we have cast, which is what we know. And we have many, many slogans, and one of it will be all students take coffee, which in nowadays might not be true. And some can call all students take calculus, and many, many which you can have, right? So this is what you need to know, just to remember that in the first quadrant, what is happening, second quadrant, third and fourth, and which ratio is positive. Please, please, please capture this and make sure that you can understand all the time when you need to deal with trigonometry. Okay, so this is the focus of what grade 12 need to know and how you have learned. I mean, you have done this in term 1, so for now you're just doing a recap, hence we are going this hurrying. Okay, so we have key identities. So if you check on the key identities there, you can see that this is the one you have learned in grade 10, and you still have to know and use them. So the one for sine, which is our sine squared theta plus cos squared theta equals 1. And we have sine squared theta equals 1 minus cos squared theta, while cos squared theta equals 1 minus sine squared theta. These two are actually derived from the first one, just so that sine and cos can be the subject of the formula. There's one more, which is a tan of an angle theta equals sine theta divided by cos theta. So these key identities, you would not find them on the formula sheet, as well as your cast and your quadrant table. You won't find that. What you need to do is to master them and know when you need to use them, because it's very important. However, the compound angle and the double angle, you're going to find them in your formula sheet, but you need to know when to use them. So if I have sine of alpha plus minus beta, what we are saying here is that if I have sine of alpha, either adding or subtracting is only going to give me this in my other side, or as what is equals to. But you need to bear in mind that when I'm dealing with sine, what changes or what alters in sine is the ratios, which is sine and cos. And then the sine itself stays the same. So if it was sine of alpha plus beta, then I will have my plus, right? So that's what determines that. If I had minus, then I will stick with minus, but the rest will stay the same. That is same applies to the cos, but with cos now, if you check, you can see it says cos, cos, and then sine, sine. But what happened is the cos, if here it was a plus, then here it's going to give me a minus, or it's going to be a minus. So cos stays with its ratio, but it changes the sign, while sine stays with the sign, but it alters the ratios. So you need just to find a way to know, master, and you can be able to refer to in your formula sheet. Double angle, we have two of them, sine of 2 alpha and also cos of 2 alpha. Sine of 2 alpha only have one, it doesn't have many, right? But then cos have 1, 2, 3. You can choose whichever that works for you better. Just make sure that you don't make a mistake here. For example, when you start, don't say it is sine squared alpha minus cos squared alpha, because that's a different context. So you just have to decide to try and make sure that you write it properly as well. I am very sure that you guys have checked that and you have understood what it is that we are trying to show you here in this context. Okay. Now, with that being said, with all these summaries that I have given you, I want you to then now settle it down, and then we can then use the information we have done to respond to the question papers that we have. So as I give you few minutes to either take out the question paper if you have it, if you have downloaded the 2024 question papers, which is last year final question papers, I just have projected it there. You can see that on the screen that we have the paper. So you can download it. You have it maybe in print from school. You can also use that, or you can just take a screenshot, and then when we come right after the break, we're going to go through them to show you how you're going to answer the question, as well as how to mark and how to get full marks to avoid the errors. I'll see you right back. Okay, let us hit the ground and see what it is that we can do. I'm sure some of you have looked at this before and you have done the question, but we're going to just do a quick run to accommodate everyone and make sure that we're all on the same page. So first of all, every time when you have the equations or when you have the information in maths, I always advise that you try and read whatever that you have from the information to the diagram before you read the questions. And after you have done that, you have captured everything you need, you then be able to respond to them productively. And that is actually a better way. So here, for example, we told that in the diagram, line OP, which is this line here. So line OP is given with point P minus 3 and minus 4. So that we already know that means we have X and Y coordinate. So with the X and Y coordinate given to us, and we know we are in trig right from there, we know we are needing R. So if we need R, we need to just quickly join our right angle, the triangle, and we start labeling productively. So that's why I said, let's start by drawing our Cartesian plane. In your space, you'd already have this and in the book as your answer book, which is already drawn. So what you're going to do there is just to combine and draw your Cartesian plane. So this is what I'm doing there, which is already given to us. So that's already what we are given to, right? You can see that. Same as what graph you are having there. I just have joined it and draw my 90 degrees or draw my right angle, the triangle there. So we are told that if I had the, the angle here, my angle is going to be angle A. So that's what we are given there. So let's see, with many, many other points which we are not using for now, but let's see, let's label. So minus 3 is X, I'm going to put it in this side, while minus 4 is Y, I'm going to label it there. We do not have the R. So let's put the R here, but we know what we need to do to find R, right? Using Pythagoras theorem. So let's use Pythagoras theorem. It's R squared equals X squared plus Y squared. It is there in your information sheet. You need not to worry. You can just go there and then you substitute the values. X is minus 3 and Y is minus 4. Please ensure that you substitute your values correctly, because if you don't, it might give you incorrect answer. So that will be 9 plus 16. You can actually go straight to your calculator and then you can get the answer. So that will be 25. But because we are looking for r, not r squared, that means we have to put a square root of 25, which the answer will be 5. So if you remember very well, in the diagnostic report, we were told that other people are writing this answer as a -5. So we are deciding not to make that mistake, because we know now better that r can never be a negative. It has to be positive, right? Yes, of course. So let's respond to 5.1.1. So 5.1.1, now we can respond to it simply because we have the value of r, we have the value of x, and we have the value of y. So they said determine without using a calculator the value of, so we're determining using the calculator the value of what? Cos A, right? So as I have said here, the square root will have to be like that. Normally it has to have plus minus the square root of 25. But because it's a distance, our answer will just be 5. So the square root of 25 is literally 5. So that's what we meant there. So as we are calculating here the cos of A, what are we going to do? We're going to our Cartesian plane, which is, you can see it in where we have drawn here. Our Cartesian plane, it does show that an angle A is here. So that means this is opposite. So -4 is opposite, r is hypotenuse, and -3 is adjacent. So cos is adjacent over hypotenuse. So that means it's a -3 divided by 5. Just by doing that, you are going to get your full marks. But they said 2 marks. So if you show them evidently that you found that r is actually equals to 5, and also the fact that the cos A have a ratio of -3 divided by 5, they'll give you full marks. But if you did this somewhere in the rough space, you did not show, they will still give you full marks for this one. The danger then become if you go and make mistakes on the other questions. Then they won't know where's your reference. My advice is write within. Do not write it somewhere else and you come back, right? So write in there. It's either you open your page on the corner there and you say rough, you write everything there, and then you come here. They will definitely going to mark it even if it's there. But if you write it on the scribbly somewhere or in the question paper, not in the answer book, nobody will know. So please pay attention to that. Then 5.1.2, let's see. 5.1.2, what do they want? They want us to answer or determine cos 2a. Excuse me. If you remember very well, cos 2a, we said it has three different equations, right? So I have chosen one because I think always to choose the first one makes sense, but you can choose any. So that is cos squared a minus sine squared a, right? I already have the solutions of this. For example, cos, we just had it here. So cos is going to be a -3 divided by 5, and then we square that, minus. So if I want to know what sine will be, I can come back to my Cartesian plane and I say sine of an angle is opposite divided by hypotenuse, for which we said our hypotenuse equals 5, right? So that means we have it as a -4 divided by 5, but that needs a square, right? If you put that quickly in your calculator, you can get to the answer right away. So that will be 9 divided by 25 minus 16 divided by 25, which is 25 will stay. Then we have 9 minus 16, which gives us a -7 divided by 25. So if you have used your calculator, you would have come to a -27 divided by 7 divided by 25 right away from here. So that's how we mark. This formula is in your formula sheet. We just want you to adapt and use the correct letters. You can see, even if in the formula sheet it was saying theta, beta, and alpha, I only used A. I did not use theta and alpha because I have adapted the formula and used the angle that is given to me. So please bear in mind. So that's where the mark goes, and the other mark will therefore go to your answer, right? The question does say without using the calculator, because we don't want to see your answer as 0.3 or 0 point something. Your answer should stay as it is here. So that's why I'm showing you how we're going to work it out to get to the solutions. I guess you guys understand that and you are happy with it and you can go, right? If you have any question, please just put it on the chat and then we will respond to it as soon as we can, and make sure that you are working with us. Okay, so 5.1.3, we are given sine of A minus B, right? So that's what we are given. Sine of A minus B, but they said if it is further given that. So this is our question. We need to solve for this, right? But if it's further given that sine B, gonna put it here, is equals to 4 divided by 5. If you remember very well, we did say that if I use my Cartesian plane, sine will be opposite divided by hypotenuse, meaning that it will be y divided by r, right? So that means my 4 represent y and my 5 represent r. So that's what it is actually in terms of letter x, y, and r. So what do we do then? We're going to try and draw a Cartesian plane that will follow these intervals, where B is greater than 90 but less than 360. So let's try and draw a Cartesian plane for that. Okay, just don't want to draw a very big one. We just need a small one. So I drawn a Cartesian plane for that. And then in the Cartesian plane, remember we have 0 here, and we have 90 there. We have 180, and we have 270 there, which revolution will take us back to 360 there. So what are they saying? They're saying that the interval is just more than 90. So this is the quadrant we are talking about, but it has to be less than 360. So we are talking about second quadrant, third quadrant, or fourth quadrant. But what will guide us then will be what is given to us in terms of y value. So our y value is positive. That simple means that everything that we are going to do, we must do it where y is positive, which is on the top quadrant, first or second. So since first is already not part of it, this one is already not part of it, we're only focusing on the second quadrant. So therefore, we are only going to draw our Cartesian plane on the second quadrant just like that. So we're going to draw our right angled triangle on the second quadrant, but not on the first, third, and fourth. So that's how you describe what is it that you are going to draw and where are you going to draw it. So let's label. We are given our r, we said is 5, and then our y, we said is 4. So we're looking for x. We don't have x, right? So let's look for x. How do we look for x? Always we go for Pythagoras theorem if we have two sides and one missing side and we have a right angled triangle. So let's use Pythagoras theorem to get that. So we're going to have r squared equals x squared plus y squared, where r is 5 and x is we don't know and y is 4, right? Then our 5 will then give us 25. Then we leave our x like that. Then 16. We need to find x only. So what we are going to do with that is we're going to move 16 from the right. But how do we move it? We're going to subtract it both sides. So when we subtract 16, we're going to have 25 minus 16 equals x squared, where 25 minus 16 will be 9. So x squared equals 9. Therefore, if I put a square root both sides, remember this will be plus or minus since I'm inserting a square root, then it means that x will be equals to plus or minus 3. Then I go back to my Cartesian plane and say, since I only need the part where I have my x, where the graph is, which is in the second quadrant, then it means I only need my x being the negative 3, right? So x will be negative 3. That's what it is. So let's write x as negative 3 instead, and then we leave it there. So now we have what we need to try and answer the question here. Can you see? So let's go to it. We have sine A minus B. So let's write it a little bit bigger. Sine A minus B. So what we need to do there is to therefore use whatever formulas we have that can help us get to the equation. So we cannot come here and say A is 3 over 5 and B is 1. No, we need to expand. So how are we going to expand? We're going to go back to our formulas that we talked about, which have something that looks like this. In your space, you're going to have it on the formula sheet, which is something like this, right, on the formula sheet. So you're going to have your sine alpha or sine A and B, depending on what they give you, but you have to adapt. So here when we expand, we are going to have it as this will be equals to, we're going to say this is equals to sine A. Remember we said sine changes the ratio. So it's sine A cos A, right? And the minus will remain. Then we have, sine A cos B. Let's do that. The minus will remain. That's the very important one. And then when we write the minus on the other side, we are then going to have cos A sine B. Cos A sine B. Like that. Okay. So when you have that, then we can start substituting our point. We can start doing the substitutions, and then we see what we have. So we did say that from the beginning that an angle that is A is this diagram. So sine A will be equals to, remember, is opposite over hypotenuse. So that's a negative 4 divided by 5. And then cos B will come from what we just have done, which is going to be a negative 3 divided by 5, and we subtract that to cos A, where cos A will be what we have calculated initially from here, which was a negative 3 divided by 5. You can just quickly go, and then you will see there is our cos A. That is a negative 3 divided by 5, which we have already done. So let's write it down, negative 3 divided by 5. And then we have our sine B, which is what is given here, right? They've given that, so we can use it as it is. So that is 4 divided by 5. You see? So after you had this, you can then now do your calculations, and then you can find your answer. So let's do that. That will be equals to 4 times 4 is 12. And then 5 times 5 is 25. Then we have minus a negative times a positive will give us a negative, right? So that will be negative 12. And then we have divide that by 25, right? Then we can now remove that. So that will be 25. Then we're going to have 12 plus 12, which will give us 24 divided by 25. So that will be the solution for 5.1.3. It does look like more work because we are actually teaching you how to do it. But if you are doing it and you have practiced it many times, it will be very easy for you to get it done as quick as possible. So how do they mark this one? They will still mark the method that we have used to actually get to the x being -3, and they will mark you for the substitution, and they also mark you for the answer. But we do have one more. So because they have given you this interval for the diagram, it does not just come for funny. It's because they want to see if you manage to draw your diagram where it has to be. So if you draw it in the correct space, they're going to give you a mark for that, a mark for finding a missing sign, a mark for substitution, and also a mark for getting a correct answer. Okay. That sounded like a long time doing, but I'm sure we can do this last one, and we make sure that we can understand it going further. This one is another one that they usually just use it to trick you. But believe me, if you have mastered your maths, this is nothing. Just make sure that you don't just rely on the formula sheet, but you also know what it is that it means from the formula sheet point of view. So let me write it down, and we can just give each other 2 seconds for us to write it down or actually absorb it, right? So we have cos of alpha divided by 2 minus 45 degrees. And then we are multiplying this by sine of alpha divided by 2 minus 45 degrees. All this is divided by 2. Okay. All this is divided by 2. So what do they want us to do? If cos alpha equals P, express the following, or the expression in terms of P. So what it is that we need to do, we cannot just come and decide that, oh, cos alpha is that. We need to find the cos alpha. So we need to do something in order for us to find that. But I always say you cannot just find it from here, because it looks like it's a challenging path, right? So what we need to do here is we need to create a space whereby we will be able to see what is related to this part. So let's go back to what we had. So this is the reason they actually give you a formula sheet. Do you see? Very important, because if you have your formula sheet in hand, then you can be able to relate. So if you look at this properly, we have cos of an angle multiplied by sine of an angle. The only time we have that is if we have a double angle of sine. Check this. Just check this and this only. The moment you have a double angle of sine, that's the only time you're going to have cos and sine multiplying together with an angle. So that's the idea we need to use. So let's write it down. We literally have, I'm going to write it down here. We have sine of 2. Let's just use any angle alpha. This is equals to 2 sine alpha cos alpha. That can be written as 2 cos alpha sine alpha. You know, it's just changing of the spaces. So there's no big deal in which one comes first. So if I see this, that literally is the same as if I come over here and I divide both sides by 2. Look at what is happening. If I come here and divide both sides by 2, I will actually have this as 1 over 2 sine 2 alpha equals sine alpha cos alpha. Just like that. The 2's will divide and I'll get 1. So if you look at it properly, can you see that there's a relationship between this and the whole of this part? Look carefully, please. There is a relationship between the two. So because there's a relationship between those two, then that simple means that you need to just use that to identify the context. Right. So let's see if we can do that. I'm very sure that you guys can. Let's see. Let's go back and substitute. So I do have my equation, so which I'm going to compare with that or relate to it. So let's write it down now. So that is equals to, so I'm actually saying the statement I wrote here in white equals to, instead of me writing the cos of whatsoever, I'm going to put 1 over 2, which is coming from here, and then I'll multiply it by sine. Look at where sine is coming from. Then instead of me writing alpha, my alpha therefore will become the whole bracket. So that is alpha, and then I'm going to put that alpha divided by 2 minus 45. That is my angle, which I'm replacing the 1 alpha with this, right? But all of this, according to the statement, was divided by 2. I hope you guys can capture that part. All of this was divided by 2. So if that's the case, that simple means that I am going to have, you see, I have a numerators and denominators. I'll multiply them across. So that means I have sine of 2 within a bracket of alpha and divide by 2 minus 45, like that. And then all of this will then be divided by 2 times 2, which is now 4. Right. I hope you can capture that. Then we can now work it out so that we remain with what we want. We manipulate, we simplify, do what we have to do. So 2, if I multiply it inside the bracket, I'll literally have only alpha, because the 2 multiplied by alpha divided by 2 will then give me just alpha, because remember this is also divided by 1, right? Then when I multiply the 45, negative 45 by 2, I'll have a negative 90. But this all is divided by 4. So that's what I got. Can you see? Okay, so that's what I'm getting there. So after I have this, what I need to then identify is that, if you remember very well when we were doing the reduction formulas, we cannot have an angle minus the number, but we need to have it as, look at this, 90 minus alpha, or somehow 90 plus alpha. In other words, we need to have it as a number plus an angle that is just a variable, or in this case alpha. We cannot have it starting other way around. So we need to fix this. How are we going to fix it? We need to start by, let's do this. We can have sine. And remember, if we have alpha, for me to move the 90 to the other side, I must just first move it as negative 90 like that, and plus alpha, right? Divide by 4. Then let's move it out. If I take out the common factor of a negative, I'll remain with 90 minus alpha. Why? Because a plus have 2 negatives. So if I remove 1 negative as a common factor, I'll remain with 1. So that's why I have this negative. So this negative 1 here, if I multiply inside, I will still get what I had there. So let's divide that by 4. But if you recall very well, in grade 11, we did learn, or earlier this year as well, we did learn about a negative angle. So this negative angle only cos is positive. Sine and tan are going to be negative. So that's why we're going to have a negative, then sine of 90 degrees minus alpha divide by 4, right? Then when we have this, we go back to our Cartesian plane and we check, is sine positive where is 90 minus alpha? Yes or no? But before that, we know when we have sine and we have 90 minus, then, or 90 plus, then sine will change, right? So when you see sine, then the name changes. So that means that this name is not going to be sine anymore, but it's going to be a cos. So we have a negative cos of alpha. But this is on 90 minus, which is on the first quadrant, and all ratios are positive. So that's what we're going to have, and we divide that by 4. So what did they say in the question? So the question was saying that if cos alpha is equals to P, then express the whole thing in terms of P. So now we know what we are talking about, or where we are, right? They did tell us if I can find something like this, then that means that is P. Just like that. So that means that my answer will therefore be negative P divided by 4. Where did I get P? From the information given. So they did tell us that whenever I see cos alpha, that means I am going to substitute it and get P. Wow, what a lesson. This was very nice. I think I actually have learned a lot. Hopefully you guys have learned as well. This is a very, very important concept that if you can get it, you'll be able to do the rest of the question properly. So I have decided to just go with this so that you guys can learn and master it, and I'm very sure that you have learned. Any question, please pop it on the chat. Do many questions that are like this, and you'll be able to get the solutions. So this is just one part of how trigonometry want you to respond to the question. You literally have 4 parts of trig. Question 5, question 6, question 7, and question 8. And all this is plus minus 50 marks of your 150 marks. So please make sure that you can respond to them. So that was first one of it. This is the second one. Question 6. If time allows, we can work with it. If not, I'm going to just give you the hints of what it is that you need to do. Then you go do it and ask us the questions where necessary. So this question, we're told that we are given an identity of cos x minus y equals cos x, cos y, and so on. In all my teaching and marking experience, I have never in my marking and teaching experience, I have literally never seen them ask this kind of question. But you know why are they asking is because you guys, most of them or most of your peers were not able to use this, to use the formulas of compound, right? So they want now to see how it's derived. So you can see that with all these changes, they just want you to know. So for example, here they said use the compound angle identity given above to derive a formula of x, cos is x plus y. So what are you going to do first? You're going to just, so what is given is cos of x minus y. So you're going to use that to get to cos of x plus y. How are you going to do it? One, you can use the common or the introduction of a negative in both sides. Since you know that we said that if you have a negative here, then this will change, right? So that will appear as well. If here you have a positive, then your answer should have a negative. Will be the same, similar, but you will have a negative, right? The derivative of this, you can find it in our platinum textbook. It's actually very nicely derived, where it shows you an example of how you can do it as well. All the concepts are derived, including the time that is not examinable, right? That's the first trick. The second one, every time you see something like this, they say hence or otherwise, they are trying to tell you that because we have given you this information, you somehow, for some reason, need to use it to get where you are going. So hence or otherwise is you can use it or you cannot for you to end up on tan x plus y. So what are you going to do there? You're going to try and work with what you have. For example, the cos of 90 degrees minus x, you need to change that to sine first, and then you reduce. Then you would have two things. So you can see if you start reducing like that, you're going to end up with something that looks like that in a way where you would have sine, cos, and then you're going to have a sine and a cos. You see that? So if you do that properly, you'll be able to then get into these solutions to end up with the tan of x plus y. It does look tricky when you look at it, but the moment you start writing, it makes sense, right? Here as well, the 6.2, you are given an equation that they want you to just solve for x, and they've given you an interval And also bear in mind that they've given you the value of f of x, which is y. So what you need to do is substitute that by 2, and then you put a square on both sides to remove the square root. Then you'll be able to get your solution, or you're going to get your equation in a proper way. Remember to change this by reduction formula, and cos will change to be sine. But because it's cos of 90 plus, that is on the second quadrant where cos is negative, so you need to remember that your sine therefore will become negative. Very, very important for you to note those kind of things, and then you'll have your flat equation. Whenever you have an equation in trigonometry, you cannot solve it in a way of you like scared of looking of sine and cos. Please just use them as like when you use K method in algebra. So you can let sine x to be like K, and then you start substituting. Just remember to go back when you answer. Another hint here is that whenever you get to the answer, there is a point where you're going to get your ratio as a negative. Right, so if let's say you get x equals negative 3 divided by 5, that negative is just a direction to say I'm going to look at my Cartesian plane. Whenever sine is negative, that's where you're going to use the reduction equation for you to answer the questions. And that same apply to all the questions that comes like that. This question paper is there online. You can find it if you need to, and you can work on these questions, factor all the questions and more, because there's many of them, but I liked it because it talks to many of the things that we do. If you are busy and you get stuck, you struggle, please ask Maski as usual. If you don't have the number up to date, please save them. It's 072 091 0388. That number is going to help you or take you to Maski WhatsApp, which is empowered by Maski Miller Learning, and it has a best AI tool that you can use, and it will support you. And when you are doing that, you get stuck, please tune on to our WhatsApp, our Maski TV, and every social. Let us know which topic you want us to help you with and which concept you are struggling with. Until we see you next time, from Maski Miller Learning, Maski TV, and Teacher Thandi. Bye.
And now we enter our next exciting chapter with the launch of Maskiverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.